Digital Electronics and Logic Design. Our subject code is nothing but 21024 for the second year computer engineering. Okay. Now we are moving to the teaching and examination scheme is there. Weekly we are having the 3 lectures, but right now we are having the 4 lectures, and our credit is nothing but D3. So for the mid semester we are having the theory, for the in sem we are having 30 marks, and for the end sem we are having the 70 marks. Okay, so our prerequisite course is nothing but your basic electronics engineering. So the our prerequisite lectures will be over in the previous 3 sessions, and I'll just and you already given the exam for the prerequisite test is there. So now we are also having the digital electronic labs. So most of the students are performing the digital electronics lab is there. So most of the students are attempting the digital electronic labs is there. So it will be based on the simulator for the online sessions only. So physically there is no confirmation from the university side whether we are having the online or a practical session. So we are doing the online with the help of the simulator. Okay. Now we are moving to the unit number 1, that is the combinational logic design. Our first chapter is nothing but the combination logic design is there. Okay. So let's start with our syllabus. What we are having in the unit number 1, that is the combinations of the logic gates. Okay. So we are having the 2 important part. In that 2 important part, we are having the logic minimization part is there, and design of the combination logic is there. So what are the terms are included in the logic minimizations? First is nothing but the representations of the truth table. In the practical sessions, I already taught you that is the representations of the truth table and or universal gates are there and the basic gates are there. So this part will be done. Representations of the truth tables. Okay. Then sum of the product, that will be called as SOP form is there. Product of sum, that is not will be represented in the POS form is there. Then simplifications of the logic functions is there, and minimizations of the SOP and POS form using the K map up to 4 variables, and Quinn-McCluskey technique is there, and then we are having the realizations of the logic gates is there. Okay, so this is about the part 1. Then we are having the part 2 also. In that we are having the design of the combination logic is there. In that we have to learn the code converter is there. So in that code converter we are having the BCD, access tree, gray code, binary code, half adder, full adder, half subtractor, full subtractor, binary adder, BCD adder, look ahead carry generations. Multiplexer will be considered as the MUX. Then in that we are having the 2 parts, that is the MUX IC 7413 and 7415. Then we are having the multiplexer tree is there. Then again we are having the multiplexers, so demultiplexers. So it will be defined as the DMUX. That is nothing but D. In that we are having the decoder. Decoder of the 2 types are included. That is nothing but the IC 7413 and IC 74154. So these are the 2 important parts in the decoder is included. Then we are having the demux tree is there. In that demux tree is we are having the implementations of the SOP and POS using the multiplexer and demultiplexer. Comparator is there, priority generator is there, and checker and priority encoder is there. So this is about our chapter 1. Descriptions about our chapter number 1. Okay. So what is included in that chapter? So this is first unit, and it will be take lots of time for the presentation. Okay. Now we are moving to the logic minimization. That is nothing but our first part. Okay. So what is given in front of you, that we are having the sum of the product and product of the sum form. So we are having the sum of the product. I already told that this will be represented in this form only. Sum of the product, that is the SOP form, and product of sum, that is a POS form. Then we have to see the standard SOP and POS forms. Okay. Then we are having the convert SOP to standard SOP form, convert POS to standard POS form, and min term and the max term. So this is important part in the logic minimization. Let's start with our first point, that is nothing but the sum of product. So here we are having the Boolean expressions. So what we can say about the Boolean expressions? Boolean expressions that will be constructed by the Boolean constants and the variable with the help of Boolean operations. Okay. So that is about the Boolean expression. So in that we are having the two part is there. That is nothing but the sum of the product that is given in front of you, and next one is the nothing but the product of sum. Okay. What is given in the sum of the product? The sum of the product, that is SOP form, is the methods, or we can call as the form of simplifying the Boolean expressions of the logic gate. Why we are using the SOP form? We required to simplify the Boolean expression. So what is the Boolean expressions? Boolean expression is nothing but we are having the combination of the constants and the variable. Okay. So SOP is what? SOP form is the method or simplifying the Boolean expression of the logic gates. Okay. The sum and product. We are having the two main parts, sum and the product. That will be derived from the symbolic representation of or and function. How it will be derived? We are having the two terms in that sum of the product. So sum is a different part and product is a different part. So how it will be derived? So it will be derived from our symbolic representations of the or and function. So or will be indicated as a plus and will be indicated as a multiplication. So it will be represent additions and the multiplications. Okay. So let's start with the one example, how we can represent the SOP of the product with the help of the or and gate. Okay. So I'm just writing the one function is given in front of you. Am I audible to everyone now?
Yes, ma'am.
Yes, ma'am.
So I'm little bit going fast, or it will be required to be a slow?
It's okay, ma'am.
I think it will be very fast.
Just a little slow.
थोड़ा सा slow चाहिए. Okay, okay. Okay, ठीक है. Okay, let's see the example. That is nothing but the FAB. This is just an example. So we are having the ABC plus A bar, B and C bar is there. So what this will be called as? This is nothing but this two term will be called as the product term. Okay. What will be called as this two term, this one product and this one is another one product. So what will be called as we can call as product sum. Okay. So these letters are there. So in front of you, we are having the letters are there, A, B, C. So that letters are nothing but we can call in terms of the digital electronics, we can call as literals. So what we can call, we have to call that is to be a literals, and combination of that literals will be called as a product sum. So combinations of this literal will be called as a product sum, and the most important is nothing but the sum. So sum will be defined with the help of the or gates, and product of sum will be defined with the help of the multiplication. So there is a यहाँ पर multiplication है, but it will be visible. So A dot B is nothing but the AB. Is it correct? So this is the A dot B dot C plus. So as sum of the product will be always represent with the help of the addition dot A dot B, A bar dot B bar dot C bar. So clear this example, everyone. So we are having the three characters, letters are there. So all the three letters are included in the product term. Clear, everyone? This one? Yes. Only 47 students are joined. We are having the 69 students are there, no?
Yes, ma'am. Yes, ma'am.
Okay, everyone understood this example? What we are doing with the sum of the product. So what we can call as a sum and what we can call as a product. Okay?
Yes, ma'am. Got it.
Got it, everyone? Shall I move to the next slide?
Yes, ma'am.
Everyone understood? If you want to take down the example, you can take down. Okay? So I will wait for the 5 seconds. Only 5 seconds, huh? If you want to take down this one, Yes.
1 minute, ma'am.
Okay, I'll be wait for the 1 minute. So you can take down whatever given in front of you. Okay. Finish. For the Dell lectures, we have to create the one separate book for the Dell.
Done, ma'am.
Done. So I'll be moved to the next slide. Then we are moving into the product of sum. Okay. So product of sum is exactly opposite to the sum of the product. So we can call as the POS when two or more sum terms. What is given in front of you? When two or more sum terms are multiplied by Boolean OR operation. What is to be given here? We are having the OR operation is here. Okay. And we are having the AND operator in between of that. When two or more sum terms are multiplied by the Boolean operation. So this nothing but we are having the sum A bar plus B. Here A dash is nothing but we will consider as a bar. Okay. So at each and every time it is not possible to give the underline for this one. So I'll just use the A bar. Okay. So A bar B dot, that is nothing but the AND operator, B plus C bar. So we are having the sum terms are multiplied by the Boolean OR operation, and the sum terms are defined by using the OR operation. The sum term is defined by using OR operation, and product is defined by using the AND operation. So this one is the OR operation and this one is the AND operation. Okay. So again, I'm saying the same example for the A, B and C. So that is equal to the A bar plus B dot B plus C bar. So this is to be about this middle part will be considered as the product. Okay. So this dot will be considered as the product and remaining two term will be considered as sum term. Clear everyone? So in which part we have to consider as a sum term and in which part we have to consider as a product. Okay, clear everyone? What is the product of sum? Yes?
Yes, ma'am.
Okay. So you want to take down this example?
Yes.
Take down this as an example. Why I'm saying this is to be take down example? Because we have to convert the sum of the product term and product of the sum. Each and every time I cannot move into the back side. So better way you have to take down it as an example and then we'll move according to that. Okay.
मॅम ते कॉम्प्लिमेंट आहे का?
A bar is nothing but A complement.
हा येस मॅम.
A bar written over there. Everyone, please just take down that A dot. This is to be a complement. This is to be a complement. A bar. A. This will be a bar. Done, everyone. Done, everyone. Shall I change the slide?
Yes, ma'am.
Yes.
Okay.
Yes, ma'am.
Now we are having some standard SOP and POS forms is there. So we are having the canonical forms are special cases of SOP and POS form. So these are also known as the standard SOP and POS form is there. So we are having the canonical form is nothing but it will be considered as the standard forms only. So whenever the term come into the canonical form is nothing but it is meaning that we are having the standard SOP or it may be the standard POS forms. Okay. Now, again, we are having the conical form. As we seen in previous slides, that is nothing but we are having the standard form is there. Okay. So in SOP or POS form, in SOP or POS forms, all individual terms do not involve all the literals. It may be depend upon the example. As I already given in the example, we are having the function ABC is there, and in that we are having the AB plus A bar B and C. This is the first product term do not have contain the literal C. So this AB does not contain the C. Okay. So this AB will contain the C? No, it will not consider, it will be not included the C here. So this will be cannot called as a canonical form. But if each terms in the SOP or POS contain all literals, then the expression will be considered as a standard or canonical form. When it will be considered as a standard or canonical form, when it will be contains all the literals. Literals is what? Yes, what is the literals? Literals is nothing but the letters that we are having in the function. So I will be just move into the backward. So this is what? ABC. These are what? Literals. ABC. So we are having the AB, but here C is missing, BC, and here is A is missing. So this will be considered as a canonical or standard form? No, this will be not considered as a standard form. Okay, so this is just an example. If there is a one literals or one letter is missing in the example, that we cannot consider as a canonical. If each term in SOP or POS contains all the literals, so what we have to contains? We have to contains all the literals. Then that expression we have to consider as a standard or canonical form. Clear, everyone? So let's start to the canonical form. So we are having the each individual terms in the POS form that will be called as the max term. So whatever we are having in the POS form, that will be considered as the max term. Then whatever we are having in the SOP form, that will be considered as a min term. Each individual term in the SOP form will be called as a min term. So what we are having in the min term and what we are having the max term. Okay. So in min term, we look for the function where the output result is the 1. So that is to be a min term. After that, we are having the max term. So we look for the function where the output result is a 0. So after that, we perform the sum of the min terms. So we can call as a sum of the product, and with the help of the min terms and max terms, we can perform the POS also. Okay. So now convert SOP to standard SOP. अभी जो example दिया है in the previous section, that is ABC, in that we are having the some missing term AB plus A bar, B and C bar. Okay. So convert what that is the thing, but we are considering as an SOP, but we have to convert that SOP to the standard. So we have to convert it to a canonical form. So the standard, we have to convert that into the standard SOP form. So we are having the first step, 4 steps is given in front of you. So the first step, find the missing literals in each product term, if any. Okay. So in that, we have to find out the missing literals. Missing literals is nothing but the missing letter is there. Okay. So we have to find out which one is a missing letter in the given function, if any. Agar hai to. Now for the step number 2, then add each product term having the missing literals with the terms formed by or the literals and it's a complement. Agar miss hai, so we have to add. Then In the step number 3, expand the term by applying the distributive law and reorder the literals. We have to expand the term. We have to expand the term by applying the distributive law. So what is the distributive law? That we already done in the our prerequisite lecture. So what is the distributive law? And then we have to reorder the literals. Okay, again we have to do some reorders. Okay, then in the step number 4, reduce the repeated product terms. Reduce the repeated product term, because we are having the a plus a, that is nothing but the a. So according to the theorem, it will be, I just mentioned here the theorem is given in front of you. That is a plus a, that is equal to the a. So if number of terms are included into the product, so we have to reduce that repeated form, repeated product form. Clear everyone steps? Yes.
Yes, ma'am.
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Okay, we just take down the one example based on the convert SOP to the standard SOP form. Okay, so one example is given in front of you. So F, A, B, and C. So we are having the 3 literals. Okay, we are having the 3 literals. We can say about that we are having the 3 letters is even in front of you. So that is equal to the AB plus BC plus AC. We can call as the A dot, that is the AND operator B, or BC or AC. So our first step is what? We have to find out the missing literals in the each product term. So this is to be a what? This will be a product term is there. So here will be, we are having the product term is given in front of you. So we are having the function ABC, AB, BC and AC. So I'll start with the last one because it is very easy to for showing me here in the PPT presentation. So we are having the AC term. So which one is the missing? Here we are missing only the B literals. Okay, so we are having the B missing letter. Okay, so for the BC, so which we are having, we are missing the A letter is there. Okay, for the next third term, we are having the AB. So which one is the missing? C is the missing. Everyone is getting now. First step, we have to find out the which one is missing. Okay, clear everyone?
Yes,
Yes, ma'am.
Yes, ma'am.
First step is clear everyone. We have to find out
Yes,
the
ma'am.
missing literals. Literal is nothing but the, do not confuse on the literals, that is nothing but the letters. Okay, so we have to find out the such kind of the literals. We are find out the missing one. Okay, so for the AC we are having the B is missing letter. For the BC we are having the A missing letter, and for the AB we are having the C missing letter. So everyone is clear with the first step. Now we are moving into the step number 2. And the product term while missing literals, its complement. So how we can add this one? कैसे add कर सकते हैं? With the help of the, it's a literal and it's a complement. Missing literals plus its complement. So यहाँ पर कौन miss था? AB is present. Missing कौन था? C missing था. So we have to miss the literal. My literal is nothing but BC plus C complement. Okay. So that is what we have to add. We have to add the literals and it's a complement. So missing letter is nothing but the C is there and C plus it's a complement. So AB dot C plus C bar. Okay. Plus second term में कौन miss था? Second term having the missing of the A letters only. Okay. So I'll just add the literals and the complement also. Plus we are having the AC. So which one is missing? We are having the missing letter is nothing but the B literal is there. So we are having the B, we are with the help of the AND, we are having the B plus B bar. So what this will be called as the missing literals and their complement. So what are these three? These three are nothing but the missing literals and their complements. Clear everyone? Step number 2 is clear for everyone?
Yes, ma'am.
So
Yes,
what
ma'am.
we have to add in that? We have to add the literals and it's a complement in the second missing term. Okay. So the clear everyone? If you want to take down, you can take down the example. Just inform me that you are taking that example. Yes, you are taking this example.
Yes, ma'am.
Done? Done with the example? Shall I move ahead?
Yes, ma'am.
Yes, ma'am.
Then next is nothing but the expands the term and reorder the literals. Okay. So we are having the expanded form A, B, C. So we are having expand and reorder. A, B, C, A, B, C bar, B, C, A, B, C, A bar, A, C, B and A, C, B bar. So we are having, so after the calculation, we are having the expand and the recorded term is given in front of you. So we are having the ABC bar, ABC, A bar, BC, ABC, AB, A, B bar, C. So we are expanding this term and we reorder the terms. Okay. Then in the fourth step, we have to reduce the term. Okay. In the fourth, we have to reduce, omit the repeated product terms. So from the given equation, which will be the repeated part is there. So we are having the, I'll indicate this one, ABC and ABC. So this will be the repeated part is there. So instead of writing this ABC in the twice, so we have to consider only one. So find out any another term will be present in here. Yes, find out is any repeated term is there instead of this two. Yes. Is there any repeated term is given?
Yes, ma'am.
No. ABC term.
Yes.
Only ABC is there and ABC is there. No other repeated form is given in front of you. So we are having the ABC. So we have to reduce the twicely repeated product term. So I'm just, instead of writing the twice, I'll just write down the only once. So ABC plus ABC bar plus A bar BC plus A bar C. Clear everyone? So according to the step, yes,
Three
yes.
times ABC. 3 times repeated.
3 times ABC.
Yes, this is also repeated. Yes, corrected. So instead of writing the, I'll just move into the arrow here also. So ABC, ABC, ABC. Okay. So instead of writing the 3 times, I'll just take down the 1. Okay. ABC, ABC bar, A bar, BC plus A, B bar, C. Clear everyone? Yes.
Yes.
Okay.
Yes.
So you want to take down this one, second, third step and fourth step?
Taken, ma'am.
इसका एप्लीकेशन क्या है मैम?
Hmm?
एप्लीकेशन इसका मैम
That
क्या
we
है?
will see in the next session. Now we just have to understand the steps first. Done, everyone?
Done, ma'am.
Shall I change the slide?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Now, जैसे SOP का है, same we are having the POS also. Convert the POS to the standard POS form. Okay. So same way we are finding the missing literals in each sum term, if any. Okay. So in the second step, we are having the or each sum term having the missing literals with the term formed by adding the literals and it's a complement. Then we are moving to the step number 3. That will be the same. Expand the term by applying the distributive law and reorder the literals. Okay. Then step number 4 will be same as SOP form. Reduce the repeated term, reduce repeated product terms. That is a given theorem is given in front of you. A plus A, that is nothing but the A. Okay. So same step we are having. So let's start with the one example. So one example is given. Okay, previous. Okay. So one example is given in front of you. In that function, we are having the 3 literals. Okay. So in that 3 literals, we are having the A plus B dot B plus C dot A plus C. Okay. So in that, first step is what? Finding the missing literals. So what is the first step? That is nothing but the finding the missing literals in each sum term. Okay. So these are nothing but the our sum terms. Okay. So A plus C. So which one is the missing literals? So missing literal is the B. B plus C. If we are having the missing literals is A. Okay. So we are having the A plus B. So which one is missing? So C is missing. Okay. Then we have to take the or the sum term with missing literal and it's a complement. So what we have to take the or the sum term with the missing literals and it's a complement. So how we can take that? The C dot C bar, BC A dot A bar. We are having the missing literal is a B, B dot B bar. So these are nothing but what? Missing literals and their complements. Clear everyone? So you want to take down this as a step?
Yes, ma'am.
I will be wait for the 5 second or 1 minute only. Okay. Done everyone?
Yes, ma'am.
Yes, ma'am.
Shall I change the slides then?
Yes, ma'am. Screenshot घेतला तरी होईल.
लिहून घ्या कारण की हे आपल्याला लागणार आहेत. Okay. Now we are moving to the step number 3rd. That is expand the term and reorder the literal. So A plus B, C, C bar, B plus C, A plus A bar, A plus C plus B plus B bar. So we are having the expanded form, that is nothing but the A plus B plus C dot A plus B plus C bar plus dot A plus B plus C dot A bar plus B plus C. So we are having, this is the expanded form and the reorder form. Once we are getting one third step, we have to omit the repeated sum term. So we are having the 2 repeated sum term is given in front of you, ABC, ABC and ABC. Okay, ABC, ABC, ABC. So this will be the repeated term. So we will write down only the one time. So the ABC, A plus B plus C dot A plus B plus C bar dot A bar plus B plus C dot A plus B bar C. So clear everyone? If the question is given, convert that POS to the standard POS form, then we have to follow these 4 steps. Clear everyone? Yes. Yes or no? Clear everyone?
Yes, ma'am.
Okay. Now we are moving to the min term and max term. So what we can call as a min term and what we can call as the max term. You want to solve one more example before moving to the min term and max term? So I'll stop the sharing and I will take the one example. The example and the steps is given in front of you. I think I have to solve the one more example based on the SOP and the POS form. Shall I stop this one? Or you want to solve the example? Okay, I'll stop this one and I'll just move into the, I'm just taking the whiteboard and we will start the one example. Okay, this will be visible to everyone. So I'll just give you the one example. Can you solve this one? Function 1. Function 1. A, B plus C bar D plus A B bar and C. So this is nothing but D. This is which term? Yes, what is given in front of you? This is which one? Convert that example into the convert into standard SOP form. Okay. Now start the example. Start solving this example. Yes. For the attendance, you join the second session with the same link only. Okay. We are having very less time. Solve this one and we will see the output of this question.
अटेंडेंस दे क्या मैम अभी?
नहीं, next section में दे दो ना.
ठीक है मैम, ठीक है.
First session is only for the lectures and examples. Okay. Today attendance is very less. 49 students is there only instead of the 53 and 54. I don't want that f1 that is equal to the 1. That is nothing but the function of ABC. So that we are having the ABCD. So function 1 is nothing but the, okay, I'll tell you this one, f of ABCD. ABCD. Okay. So in that we are having this one.